Hello guys, welcome to Ramta Solutions. In today's video, we are going to be looking at derivatives of a cubic functions. Right, derivatives of a cubic function. Now, you know that a cubic function has this equation, y equals ax squared. I know you prefer to say f of x, right? Equals ax cubed rather, plus bx squared plus cx plus d, right? So, having said that, this we know it is a cubic function. Now, then we can look at cubic equation. Then let's find the derivative of a cubic. It will be, let's see, y prime. If you like, you can say f prime of x, right? You can call it f prime of x, or you can call it dy dx. It's totally up to you, right? So this, the first derivative will be drop the 3 multiplied by a, which is 3a, x, then the power will be 3 minus 1, meaning 2. Therefore, you have 3ax squared. In the same way, drop the 2. This becoming 2b. With the x, it was to the power 2. When you subtract 1, it will be to the power 1. Plus, the power here is 1, so this will become c. And since it's 1, subtract 1, it becomes 0. So x to the power 0 is 1. Then obviously this one will become 0. Now, this is, when you look at it, 3ax squared. What do you call this? It is a quadratic. Alright? It is a quadratic. Now, let's go to the second derivative. The second derivative, if you like, you can call it d square y over dx squared. Alright? So what is this? Doing the same thing. This will become 6ax plus 2b. So what kind of a function are you getting here? Power is 1. It must be linear. Alright? It must be linear. It's a straight line. Now let's proceed now to the next one. This, if you like, you can call it d cubed y over dx cubed if you like. It is y third prime, right? So y3 primes, this will be in the same manner, it will be 6a. Now what is this? This is a constant line. Alright? It is a constant line. Can you guys see that? It is a constant line. So derivatives of a cubic becomes with 1. A cubic, when you differentiate it, you get a quadratic. Further differentiation, you get a linear function. Further differentiation, you get a constant. If you go to fourth derivative, you will get 0. Okay, but you don't have to go there. It's a waste. Now let's try an example. Example, if y equals x cubed minus x squared minus 8x plus 12, draw the graphs. Draw the graphs. 1, y, 2, y prime, 3, y double prime, 4, y triple prime. Remember, first derivative, second derivative, third derivative. Right? Perfect. Let's go now. Now, for our solutions, we had y equals x cubed minus x squared minus 8x. Did we say plus 12? Yes, plus 12. Now, number one, we're looking to draw this function here. We know y equals x squared, right? Y equals x squared, x cubed minus x squared minus 8x plus 12. What is its y-intercept? We know the y-intercept is the constant here, which is 12, easy to tell. So it is 0 and 12. Now let's get the x-intercept. The x-intercept, we know, let's see, when x is 1, we must say y is 0, right? So x cubed plus x squared, no, it's not plus, it's a minus. Minus x squared minus 8x plus 12 must be equal to 0. So we need the value of x that will make this equation to be, rather we need the value of x that will make this equation to be equal to 0. X equals 1 or minus 1 won't work. X equals 2, I think it'll work. Let me try. 2 to the 3 is 8, minus 4, minus 16. Okay, this is minus 28. Okay, x equals 2 works. So we'll use x equals 2. Therefore, we'll say this is x minus 2, close, open brackets, leave a space, x squared, minus, leave a space, x, minus, leave a space, close, equals 0. So x cubed divided by x is x squared. Okay, we are fine. I don't have to add anything here. Now this guy here must be negative x squared. So negative 2 times x squared will be negative 2x. This guy times this guy, when we sum them, they must give us minus x. So this means this middle term must be positive x. Okay, so I'm going to leave it as positive x. Now, 12 divided by negative 2 will be negative 6. This is working. Okay, so I know there are those who are not familiar with this method. I will show you a different method, but let's finish this quickly. It will be x minus 2, and then this will become x minus, I think, minus 3, and then x minus 2. But this guy here must be positive, right? So as you can see, guys, the x minus 2 is repeating. That means it will also be a turning point. Okay, that means it will also be a turning point. So we have x equals 2 or x equals minus 3. These are our x-intercepts. So we have minus 3 and 0. And, oops, you can't see here. So they are minus 3 and 0 and 2 and 0. Remember I said this will also be a turning point because I can see it is repeating. Do you see it? It's occurring twice. So this means it will also be a turning point. All right. Perfect. Now, stationary point. Now let's talk stationary point. Let's talk stationary points. We will need y prime. So we said y prime was 3x squared. Will it be? Yes. Let's go back to check. So maybe let's just do it here. Y prime will be 3x squared minus 2x minus 8, isn't it? Now, what about y double prime? This guy here, we remember with y double prime, we must differentiate y prime. So it'll be 6x minus 2. And then y triple will simply be 6. Do you guys see this? It'll simply be 6. Okay, so now let's go back. So we said y prime will be 6x squared minus 2x minus 8, right? Minus 8. Now to find the stationary point, the derivative will be equated to 0. So this then becomes 3x squared minus 2x minus 8. And this we can factorize easily. It'll become 3x minus, allow me to say 4, minus 4, and then this is x minus, allow me to say 2. The bigger factor must take the sign of the middle term. This will be bigger, so this must be positive, right? This must be positive, right? So 0, not 0. Let's not waste time. Let's just say here we can see x equals negative 4 over 3, or x equals positive 2. We did find that f of 0, not f of 0, f of 2 was 0, right? So now, on our calculators, let's confirm f of 4 over 3. Remember, guys, I said f even though I'm aware that we used y. Okay, even though I'm aware we used y. So maybe to be consistent, I'm gonna use y. Okay, I'm gonna use y, and I'm gonna say, in this case, I'm gonna say y when x is this guy. And here as well, let me just call it y, but we're going to confirm. Okay, remember, y, as a reminder, y was equal to negative x cubed minus x squared minus 8x plus 12. So need you to now, where there's x, I need you to put negative 4 over 3. Remember to put it inside a bracket. Okay, perfect. Let's go, guys. So let's confirm. Taking out our calculators, let's confirm what these are. I will also give you my value shortly. Let's see. I don't know about you guys, but I got 18,52. Okay, I got 18,52. And with this one, I think I can also do it. It'll be, we did do it. It's 0. It's okay. Right? It's 0. It's okay. So the stationary points are, stationary points, remember your turning points. They are negative 4 over 3. By the way, this one, if you don't want to write it as a fraction, you can just say 500 over 27, but I don't like that. Okay, I don't like that. So let me just leave it as a decimal. And this one here, 4 over 3, could be written as 1, negative 1,33. And this one is 18,52. Whereas the other one is 2 and 0. Right. So these are the important points you need for your cubic. Okay. So remember that cubic was A, meaning it should end with a smiling face. Now let's remind ourselves the x-intercepts. What were they? Let's go back. The y-intercept, I remember it was 12. Right, the y-intercept was 12. So let's just look for it. Okay, maybe I should take it a bit down. The y-intercept was 12. Right, so it was 12. So let me just say somewhere 12 is here. And then, I don't like it. I'm going to say 19. And then, 18. I'm going to say 18 and I'm going to say 12 somewhere there. And then, yeah, now that's better. Okay, and then I'm going to have a line here. Then, remember we had 1 comma whatever, or negative 1 comma 33. We had a 2 somewhere there. And then we also had let's go back to check our x-intercepts. It was, y-intercept was 12 and the other one was negative 3, x equals negative 3. Good. X equals negative 3 will be here. Now we are good. So here is the x-intercept and here is another x-intercept. Here is your y-intercept. We said stationary point was negative 1 comma 33 and 18.52, which will be, let's say, somewhere here. And then another one was at 0 and 2. So it ends with a smiling face, right? It ends with a smiling face. Okay. It ends with a smiling face. Right? Let's see now. Okay. Uh-huh. Oh yeah. Happy? So this, so this is your cubic, right? This is your cubic graph. Now let's go to your quadratic. Your quadratic, we said y prime was equal to 3x squared minus 2x minus 8. Let's remind ourselves. Yes, 3x squared minus 2x minus 8. So what are we seeing? Let's see now. What are we seeing? First things first, what is the y-intercept? The y-intercept is the constant, which is 0 and negative 8. Okay, cool. What about the x-intercepts? Now with the x-intercepts, okay. With the x-intercepts, we will say this means 3x squared minus 2x minus 8 equals 0. And we were able to solve this, right? So going to the next page. We said 3x squared minus 2x minus 8 equals 0. So we said this was 3x plus 4 multiplied by x minus 2. And we said this is x equals negative 4 over 3 or x equals 2, right? So we had negative 4 over 3 and 0 and 2 and 0. These are our x-intercepts, right? Now, how about turning points? Once again, you can call it stationary points or turning points, but because we are used to calling them turning points, let's just do this. Turning point. What do we need? Axis of symmetry. So, axis of symmetry. So, axis of symmetry, x equals negative b over 2a. Remember, this is the b related to the quadratic. What is it? It is negative 2. Then, what is the value of a? It's positive 3. So, it's 2 over 3. Now, what is this? This becomes 1 over 3. Right? Now, we're going to substitute this into, let's say, x equals y here, x equals 1 over 3. We're going to substitute it into the equation of the quadratic, the first derivative, meaning what is x? We're going to put 1 over 3, all right? We're going to put 1 over 3 and tell us what is the answer. Let's see. 3 into 1 over 3, close, square, minus 2 into 1 over 3 close minus 8. What do we get? So here we got negative 25 over 3. Therefore, turning point is, the turning point here is 1 over 3 and negative 25 over 3. Negative 25 over 3 is equivalent to, I think, 12,33, isn't it? 12,38. No. Yeah, 8, not 12. 8,33. So it's negative 8,33, whereas 1 over 3 is the same as 0,33. Right. Now let's go confirm. We have almost everything we need. So here our y-intercept was negative 8. All right, no worries. Think we are headed somewhere. We are headed somewhere. Now let's see. Negative 8. Okay, shouldn't be going. So I'm gonna say 2, 4, 6, 8, 10. So negatives would do, and then we have 1, 2, 3. 1, 2, 3. Okay, and 1. Okay, just 2. All right, so we are good. Let's see now. So we said turning point, rather x-intercept, was negative 1,33, and x equals to negative 1,33 could be here. We said the y-intercept was at negative 8, and we said the turning point was 0,33. It's somewhere here, and the 0,33 and 8,33. Let's say it's somewhere here, right? So this is y prime. Did you guys see that? This is y prime, right? I need you guys to note some points. The point that I want you to note is this one here, and this one here. Okay, I want you to note them. And let me go to the previous graph that we drew. This point here, and there should be another point somewhere there that changes concavity. Okay, point of inflection, which I know I didn't mention. Point of inflection. So the point of inflection is supposed to be 0,33. I want to believe that. Okay, but let's go. So now we are done. We found the axis of symmetry, everything, turning point. We are done. Now let's go to the linear. Going to number 3. Number 3, we go into the linear. Y double prime will be 6x minus 2. As you can see here, the y-intercept will be 0 and negative 2. What about the x-intercept? X-intercept will be 6x minus 2 equals 0. Therefore, 6x equals 2. X equals 1 over 3. Remember, you said this is 0,33. So this is fine. We can leave it here, right? We can plot our thingy there. And here, what did we say it was? It was, minus 2. Okay, cool. So I'm just gonna be careful there. And then this is 1, 2. And this is 1, 2, 1, 2. And then this is 1. So y. So we said y-intercept was negative 2. Maybe let me go a bit down. It was y equals negative 2, and the x-intercept was 0,33. The line is not nice. Let me just fix it nicely. Okay. Nice. So 0.33. I want to imagine it here. Then we plot our graph. But, okay, this is y double prime. Okay, this is y double prime. I want you to note this point here. I want you to note this point here. Okay, I want you to note this point here. Right? I want you to note that point. Happy? Great. Now, having said that, let's then go to the fourth one. Let's go to the fourth one. The fourth one, the fourth one, we're looking at y triple prime, which is going to be 6. With this one, we don't have to waste time. Right? With this one, we don't have to waste time. It'll be 8, 6, 4, 2. Let's see. Nice. 1, 2, 3. Even though I don't need it. 1, 2, 3. I don't really need these values. -1. Right? So with this one, we say y equals +6. Where is it? It is this line here. So y double triple prime. Do you see that? Y triple prime. You guys have seen now all the graphs. Alright. You guys have now seen all the graphs. However, this one does not necessarily tell us any relationship whatsoever that we got in the previous two. Now check. You see this point here? This point here is x equals 0.33. What is it? It is the point of inflection of what? Of the cubic. And it is axis of symmetry. Axis of symmetry is x value of the turning point of a quadratic. Okay? So let me just change the color. Okay, let me do this. Yeah, let me change the color. Axis of symmetry of a cubic. Sorry, point of inflection of a cubic. And axis of symmetry of a quadratic. Right? So, x-intercept of a linear is a point of inflection of a cubic, is an axis of symmetry of a quadratic. Remember, axis of symmetry of a quadratic is the x value of the turning point. Okay, so this is the information we're getting. Let's go to the quadratic now. On the quadratic, what is this guy here? Let me change the color. This guy here is turning point, but I'm referring to the x value only. So with the x value, what does it tell us? It is the point of inflection. All right. It is the point of inflection of whom? A cubic. And x-intercept of who? The the straight line of the of the cubic, and it is the x-intercept of the linear function. Okay, of the linear. Okay, now these two guys, what are they? They are x values. They are x values of stationary points of a cubic. X values of stationary points of who? Of the cubic. Okay. You guys get it? X-intercept of a quadratic are x values of stationary points of a cubic. Okay. Perfect. Now, let's then go to our cubic. Now we on our cubic. Where are you, Mr. Cubic? Okay, Mr. Cubic, I'm going to add so much information on you. So I will say these guys here, the x values only, ne? X values only, x values of a cubic, what are they? They are x-intercepts. Right? Of what? They are x-intercepts of the quadratic. Alright? They are x-intercepts of the quadratic. Then let me further add information here. Point of inflection. Right? Point of inflection, what is it? It is axis of symmetry of who? By now you know. Alright? And it is also x-intercept of who? By now you know. It is axis of symmetry of a quadratic. It is x-intercept of a linear. Right. It is x-intercept of a linear. So this is the relationship that you are getting from derivatives of a cubic equation. Okay. This is it, guys. I hope this will help you. Bye bye.